Okay, last lesson of Unit 4, Quadratic Inequalities. We're going to graph a thing. We're going to solve a few examples algebraically, and then we're going to peace out and be done. All right, here we go. Oh, let's go to the, you can see. There you go. Now you can see the thing. I can see the thing. I could see the thing before, but now you can see the thing. So our first thing is we're going to graph that thing. How many times can I say thing at the beginning of the video? Only the shadow knows. Okay, so we're going to graph this just like we'd graph any other quadratic. Now, I'm going to kind of do extra work for this because I want to kind of use this particular example as kind of a taking several other concepts that we learned in this lesson and kind of combining them into one thing. This is kind of a little bit more like something you might see on a pre-cal problem with a quadratic or whatever, where you've got to do have all these bits and all these really specific points and whatever else. But so we're going to kind of smoosh it in with this. See what kind of information, excuse me, we can glean about this quadratic. So what kinds of things can we figure out about a quadratic? First of all, you know from doing a lot of this kind of stuff that this inequality, that just means we're going to dash it or solid it and then shade it somewhere, right? Other than that, we pretend like this is an equals. Yay? Good. So we're going to pretend like that's an equals. We're going to do the thing. So let's think through some things that we can find out about this. So let's start by finding the vertex of this quadratic, right? That's pretty easy peasy and would probably be useful because if we have the vertex, then we can kind of figure out some things about graphing it, right? So let's find the vertex. Find the vertex, we use for the x part, we use the opposite of b over 2a. So in this case, the opposite of b is 2 over 2 times a, which is 1. So negative 2 over 2, right? So that's negative 1. That's the x part of the vertex. Now to find the y part of the vertex, we're doing y of negative 1, right? I'm going to kind of turn that into function notation a little bit, make it useful-ish. I'm going to just put equals here, even though it's a greater than. Why not? We're finding a specific point, so we're finding out what it equals, not what it's greater than. All right, so we're going to put everywhere where there is a negative, everywhere where there is an x, we're going to plug in negative 1, right? We've done this quite a bit before, right? We've seen all of this before. So we're going to take and we're going to put a negative 1 where the x is, and then we're going to simplify, right? Negative 1 squared is positive 1. That's an easy mistake to make. Negative times negative is positive. Excuse me. 2 times negative 1 is negative 2 plus 1. So negative 1, 1 minus 2 is negative 1 plus 1 is 0. So the vertex is the ordered pair negative 1, 0. Let's go ahead and graph it. Let's graph it. Can you tell that I'm tired? It's getting late. It's only 7:45, but I'm getting old and tired. And Thanksgiving break was last week, so brain is a little bit fried. As you young'uns would say right now, the brain is not braining today. Hopefully it will brain well enough for you to understand. I don't know. Things are happening. Let's put this point on the graph. So negative 1, 0. Look, Mom, I did it. What else can we grab from this? Just kind of looking at it. This up here is in standard form. If it's in standard form, we know that C is the y part of the y-intercept. So we can grab the y-intercept just from that. The y-intercept would be the point 0, 1. So that would be right here, 0, 1. Y-intercept. So we also know it's positive, so it's going to go something like that, right? Let's see what else we can find. So I was going to say we could factor this thing to find the zeros, but we already discovered that the vertex is a 0, so it's only going to have 1. Let's not waste our time, right? Let's put a dot right there. So what else could we do? Well, we probably need at least 2 more points. Let's figure out a point on this at right here and a point right there. Well, that's at 1 and then at negative 3. So let's find y of 1 and y of -3. So y of 1, we're going to take, and everywhere there's an x, we're going to put, oops, forgot the plus, sorry. Also, the air is dry, so, brain not braining, throat not throating. It's all terribleness. I don't know what's happening right now. It's going to be fine. All right, we're going to plug a 1 in for each one of these. 1 squared is still 1. 2 times 1 is still 2. Plus 2 plus 1. So we get 1 plus 2 plus 1, which is 4. So the point, 1, 2, 3, 4. Here's what's cool. You ready? You remember quadratics? You remember the cool cheat code here is this is a symmetric shape, which means that this one is going to have a mirror image right there. Look at that. So now let's finish graphing the thing. We got enough dots that we can connect them and we can understand what's happening. Now, so how do we graph this inequality? Well, first of all, it's not equal to, it's just greater than. So it's going to be a dashed line, which is great. It's easier to graph a quadratic that way because then it's okay if it's a little bit off. You can just kind of YOLO it and hope that it kind of works out about right? Look, Mom, I did it. All right. Now, are we going to shade above it or below it? Well, it's greater than, so we're going to shade above the thing. Shaded above the lot of the quadratic. Easy peasy, lemon squeezy. There it is, done, in the bag. But not the lesson. You thought you were excited, but no. Look at the runtime. It's longer than 7 minutes. Let's do a couple more examples. We don't need this picture anymore because, so if you're one of my students and you're watching this video, if you're somebody else's student, you got to do whatever they tell you, right? If they want you to solve it by graphing, just do it like we just did it, right? But if you're one of my students and the instructions in the book say solve by graphing, just disregard that and just solve by any of the methods for solving a quadratic we've already learned and check at the end. You're going to have to check at the end either way. That's going to be a step. And so, yeah, don't solve it by graphing. Who's doing that? Who actually does that? Why? This book's got 3 examples of solve it by graphing. Why? Who's doing that? Are you doing that? No. Okay. So, our first best, hopefully, this factors. Because if this factors, let's solve it that way. Because that's so much easier than completing the square or that big old giant quadratic formula or any of the other nonsense. Let's try it. Let's see if it factors. So, to factor, whoa, we got our crazy brush here. Whoa. Let's make it smaller. Maybe with this scattered brain, maybe this video will be more entertaining. Hopefully it's more entertaining and also useful to you. Hopefully it's both. That's the firm hope, because at the end of the day, you're supposed to be learning math, right? So first step here, of course, if we're factoring, 2 sets of parentheses. We'll cross our fingers and hope it works. So 2 things that multiply to get the first term, so x and x, because x times x is x squared. So far, great. All right, so we have the options of 4 and 2, 8 and 1, right? Those are our options. I think I see something that's going to work. Do you see it already? How about 4 and 2? Smiley face. Do it work? 4 times 1 is 4. 1 times 2 is 2. Can we add or subtract these to get positive 2? Yes, we can. Put a minus and a plus. Does the inside work? Positive times a negative is a negative. It factors. Yay, happy days. So now here's what you need to think about. So I am going to, I said I'm not going to solve it by graphing. I am going to kind of sketch a bit of a graph because we need to figure out our answer. And yes, you have to do this part, right? Hey, this last bit. So I'm going to kind of graph the solutions. So remember that the signs are going to flip. So it's going to be x is plus 4 is less than 0. What is that? What? kind of 4 happened there? Brain not braining, throat not throating, fingers not fingering. We're going to make it. We can do this. All right, so we're subtract 4 from both sides, and we end up with x is less than, maybe, -4, right? And this one, we've got x minus 2 is less than 0. So we add 2 to both sides. We end up with x is maybe less than +2. I'll show you the maybe. Oh, phone notification sounds. Brain not braining, throat not throating, fingers not fingering, phone arguably phoning, but we don't want him to do that. So, continuing on. So, we got -4. I'm not really trying to sketch this hardcore. I'm just getting this so I can figure out what to do next. So, what we need to know is, does this inequality come out true if I put a number from over here, or over here, or over here? So we are checking each one of these 3 zones. That's a question mark. I don't know why he turned into a 3. Maybe he just wanted to be a 3. Leave him alone. He's a question mark. All right? So we need to check each one of these zones here and see whether it works. So let's pick a number over here. I'm going to pick -5. We could pick -2,336 if we wanted. I'm just going to put -5 because -5 is over here. Seems reasonable. So let's plug that in here. Let me switch colors so we can know what's happening. So we're going to plug a -5 in here. -8. And we want to know, is that less than 0? See or no? Right? -5 squared is 25 minus 10. Why do I keep leaving out the pluses? I don't know. Same reason as everything else that's going nutso in this video. It's fine. It's one of the weirdest lessons I've ever taught, but we're going to be okay. 25 minus 10 is 15. 15 minus 8 is 7. Is 7 less than 0? No, not less than 0. So we're not, so it doesn't exist over there. Excuse me. So that doesn't work. What about this little middle region? If you can put 0 in, which we can because 0 lives in here, it's probably about like right there-ish, more or less, right? If you can put 0, oh, what is that? If I can put a 0 in there, put a 0 in there, because 0, I'll show you. I'll write it all out. We can do this. 0 squared plus 2 times 0 minus 8. You see what's going to happen? You see what the magic is? This is just going to go. So is -8 less than 0? Yes, it is. So this one works. Right? What about this guy over here? Let's plug in 3. 3 seems reasonable. Again, we could put 12,486 if we wanted. Just anything over in this region. So we're going to put a 2 right here, squared plus 2 times 2 minus 8. And we want to know, is that less than 0? 2 squared is 4. 2 times 2 is also 4. Imagine that. Minus 8. 4 plus 4. Oh, I put in a 2. That's not going to work. Of course, I was about to get a 0. Like, that's a, what? Oh, because I put in this one instead of the 3. Why didn't you stop me? Because you aren't good like that, I guess. I don't know. 3 squared is 9. 2 times 3 is 6. 9 plus 6 is 15. Minus 8 is, again, positive 7. That's interesting. I don't guess it's that interesting since it's a quadratic. But, you know, whatevs. Is 7 less than 0? No. So where we are interested in is in this section. This quadratic, by the way, probably looks something like this if you were to like put a y here and then graph the thing out, right? So that's what she looks like more or less. We want this. Now, why we drew this picture is not really because that's the answer. It's because that lets us easier kind of write this interval as a compound inequality, right? So when we have from here to here as a compound inequality in between, what we do is we write the smallest number, always write the smallest number first, so -4, and then we're going greater than that, right? And but it's going to be less than the other number, right? So it's in between. If your solution is in between the two dots, it's always going to look like this with both less than symbols. With smallest, it's always smallest number on the left side, biggest number on the right side. So that's that. Let's do another one. See if we can get some more things. How we doing? Fairly okay. More or less fine. All right, let's do this one. So hopefully he factors. Probably doesn't. But let's try. Let's try anyway. Hope for the best. Hope springs eternal. 2x and x, because 2x times x is 2x squared, right? Only option, which is good. We like that because we don't have to check as much. So let's try 5 and 1. We could try 5 and 1. We can try 1 and 5. Does 5 and 1 work? 5 times 1 is 5. 2 times 1 is not 1. 2. Can we add or subtract that to get 4? No, we can't. Sad days. Okay. All right. What about, so we need to, before we quit and say, oh, this doesn't factor, we got to change the order, right? So we did 5 and 1. Let's do 1 and 5. You can probably already see it's not going to work. Woe is me. Woe is you. 1, 2 times 5 is 10. Can we add or subtract that to get that? No, it doesn't work. So what are we going to do? So we have two options. We could either use the quadratic formula or we could complete the square. Either one. I'm going to complete the square because, let's face it, I know that's your favorite of those two options. I already know. It's fine. It's fine. You can be wrong. So the quadratic formula is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a, right? So we're going to do that, but with bubbles, parentheses, where the letters are. So we're going to say x equals, it's not really equals, right? It's greater than, but we'll deal with that in a minute with our intervals and all that nonsense. So, excuse me. We're going to write this with bubbles. So b squared plus or minus b, no, not squared. I'm telling you, y'all. Why didn't you stop me? I feel like this is big. Minus 4 times a times c all over 2 times a. We're going to plug in our b. Our b is 4. Plug in our b again, which is 4 there as well. We're going to plug in our a, which is 2, and our c, which is -5, and a again, which is 2. So let's simplify him on down. -4 is -4. What? It is. Excuse me. And 4 squared is 16. Minus, let's see, 4 times 2 times -5. It's going to be positive because there's two negatives. So plus 8 times 5, which is 40. 2 times 2 is 4. It's great, glorious, grand, all the things. Equals -4 plus or minus the square root of 56 over 4. Now, here's the thing, ladies and gentlemen, boys and girls, damas y caballeros. Normally, when we're having an equation, we'd want to reduce this, simplify it, pull a 4 out of it, all the things, you know, and get him all simplified and situated, and we circle that exact answer. However, this is an inequality, so we can't just do that. We've got to get the decimal equivalent because we need to be able to check those intervals and all of those things. And because it might be greater than a number and less than a number, all the things. We just have too much information to give with this. There's probably some super fancy schmancy way to write this formally in exact notation, but I don't know it, and so I'm not going to teach it. So there it is. So all that to say, we need to get the decimal equivalent. Let me pause and pull up my calculator. And we're back. You didn't notice. It's fine. So this is how I would punch this in the calculator. So this is one of the cases where I would actually use the negative key for this -1 here in the front. And I would kind of do it in two phases. So I would go -4. Remember that on your calculator, the negative button is different than the minus button. On this one that I'm using, my negative's here. Yours is probably somewhere else. And my minus, of course, is over there. So -4, I'm going to do the positive one first. So plus the square root. Square root on mine is shift here, 56. And I'm going to go ahead and hit enter. So I'm going to go ahead and do the top. And then I'm going to take that, and if I just hit divide, you notice it puts A and S. Your calculator probably does the same. All the calculators that I recommend for this course have that feature where it automatically pulls in this previous answer. You've probably seen this before. All right, so this answer divided by 4, enter. So approximately equal to 0.87. 0.87. It was positive, right? Yes, it was. Okay, so now let's get the negative version. So we're going to do the same thing, but with minus in the middle. So negative, that's right. -4 minus the square root of 56. Enter. As that. Double check. Looks great. Then we hit divide by 4. Enter. So it's approximately equal to -2.87. Approximately equal to -2.87. So this is a parabola opening up, and it's got, this is 0.877, and it's -2.87, right? So we need to check things on this here graph. We need to check this interval and this interval and that interval, right? We got to check all of those. So what's a number over here? How about -3? That sounds reasonable. We're going to plug a -3 in here and see if it works. So 2 times -3 squared plus 4 times -3 minus 5. And is that greater than 0? -3 squared is +9. Easy mistake to make, right? Negative times negative is positive. 2 times 9. 4 times -3 is -12. I'm going to go ahead and put that in parentheses instead of the dot. I think that's going to be clearer. Clearer? Is that a word? I don't know. Something. 12 minus 5. You're like, it's not funny anymore. Just teach me the math. What's 2 times 9? 18. +18 minus 12 minus 5. 18 minus 12 is 6 minus 5 is 1. So is 1 greater than 0? Yes, it is. It works over there, right? What about here? Well, this is a case where we got the 0. So remember what's going to happen is it's just going to whoosh. So is -5 greater than 0, right? Because I put the 0 here with the thing and the plus the 0, and it's still just -5. Right. So -5 is -5 greater than 0. No, it doesn't work right there, right? Doesn't work in that region. What about this one? So let's put 1 in there. That sounds nice. That sounds easy peasy. So let's do 2 times 1 plus 4 times 1. Excuse me. -5. Is that greater than 0? So this would be 2. Plus 4 minus 5 is greater than 0. Is it greater than 0? 2 is 4 is 6 minus 5 is 1. Wow, symmetry is a fun thing. We like symmetry. And it works, right? Happy days. So it works over here. So how are we going to write that? So we, again, have to start with that smallest number. So to write our answer, we have here, -2.87. Now this time, we're shading, essentially shading these sections over here, right? And so it's going to be less than that. So x is less than. Now I know I'm drawing a greater than symbol, but I'm going to put the x over here, right? And then it is greater than that. Now you notice that they're both pointing to the right. If your graph is going this way, out like this, your shader regions, it's always going to be pointed to the right, as long as you do it correctly. Let's do one more. Uno más. Whoa, that's exciting. There she blows. So, will it factor? Let's see. So, if we're going to try to factor this guy, which sounds like a great, grand, and glorious idea, we need everything on one side and 0 on the other side. So, we're going to start by, what is that? Minus 18 minus 18. That cancels, leaving us with x squared minus 3x minus 18 is less than or equal to 0. Let's hope it factors. Maybe it will. Two sets of parentheses. Less than or equal to 0. X times x is x squared. 18, we could do 6 and 2. We could do, 9 and 2. 6 and 3. That sounds promising. 18 and 1, right? Any of those. Let's try 6 and 3 and see what happens. 6 times 1 is 6. 1 times 3 is 3. Can we add or subtract those to get a negative 3? We sure can. Yay! It's not all bad news, because if we put a minus 6 plus 3, bring there and there. Minus times a positive is a negative. It's all happy. So we've got to check our intervals. I'm really just putting it on the number line just to kind of visualize what I'm going to write later. It's just easier to see and think through. Now, why did I switch the signs, right? Again, that's like that other example, because x minus 6 equals 0. Add 6 to both sides. X equals 6. And do the same thing for the other one, right? So the signs will flip, right? We've done that half a dozen times at least already. Now, so we need to check this interval and this interval and this interval. So what are we going to plug in from over here? How about negative 4? You see what we're doing? We're just kind of thinking through things. Just picking easy stuff. So we're going to do negative 4 squared. I'm going to go ahead and plug it in up here at the top because it feels like less work. Minus 3 times negative 4. And we want to know, is that less than or equal to 18? See or no? Negative 4 squared. 4 times 4 is 16. It's positive 16 because the negative times the negative is positive. And then plus 12. Is that less than or equal to 18? 16 plus 12 is 28. Is that less than or equal to 18? Sure as heck isn't. So it doesn't work over there. We'll double up. Do the X and the frowny face. Doesn't work. Let's do one in here. Let's pick 0. And just be like, is 0 less than or equal to? I better write that one out. I'll write that one out. We'll do one all the way, and then skip to the end, and then do one all the way. We'll give you a nice Oreo sandwich of doing things. We're going to plug 0 here. Minus 3 times 0. Is that less than or equal to 18? 0 minus 0 is... You see what happened? You got it? You got it? We got it? We're on the same page? Good job. So proud. 0 is less than 18. Yes, it is. There. Happy face. Let's do it like a surprise face. It almost looks like a evil Muppet. I don't know. Something. He's happy. It's worse. Getting worse and worse. How about over here? Let's plug in a 7. It's probably going to come out to be 28. Let's see what happens. So we're going to plug a 7 in here. Squared minus 3 times 7. Is that less than or equal to 18? 7 squared is 49. Minus brain freeze 24. No, 21. 21. Is that less than or equal to 18? 49 minus 21 is, gasp, 28. What? Symmetry. No, it's not. x. I should put that same face for a frowny face. There. So we're going to graph in between. So we already learned how to do that. It's easy peasy lemon squeezy. It's going to be -3 less than symbol, but it's actually greater than. X is greater than because it's that way. Another less than symbol. 6. Now we're done. Now it's finished. 30 minutos later. Hope it was helpful and wasn't just so chaotic that it was useless. If you're one of my students, I shall see you in class. Do your homework, all of those things. If you're not one of my students, let us know down in the comments how else we can help you, or just, how else you can make fun of us or whatever else with math and science and homeschooling and all of those things. Have a great, great day. Bye-bye.